We're gonna start just like what we did last time. If you didn't get the chance to watch that video, here's the link for it over here. We're gonna go over the categories. So we have P1 for the fundamental knowledge. And in my opinion, these are essentials. You cannot skip these. These are just the starting point. This is how you build a solid base from which you move on to the different levels. P2 is pretty much the working knowledge. It's the knowledge that you need to acquire for you to be able to be productive and maybe even take on the role all by itself. Obviously, that doesn't mean that you need to know everything before you take on a software architect type of role. It would be very helpful for you to ramp up much quicker and for you to be able to add much value if you pick up these topics. P3 is pretty much going again above and beyond. This is non-fundamental knowledge, non-essential. If you know it, all the best for you. If you don't, I think you should be okay. P4 is everything optional. Again, it's quite similar to P3, but like the optional topics are really circumstantial and they depend on the context and depend on other factors for you to really spend the time and invest the time in learning them. And before we start our deep dive, also let's clarify a few misconceptions. Misconception number 1, you will not become a software architect if you study all of these topics. This is a role that you sort of evolve into. It requires a lot of hands-on experience. It requires a lot of industry knowledge. You might even need to jump in between different industry verticals before you develop the maturity for you to be able to handle the responsibilities of such a role. You need to have worked with a variety of teams, different cultures, different ways of working, different pressure environments. These things matter way more than the length of time you spent in the industry, as well as how much theoretical knowledge you have. You could study all the theory in the world, but if you don't know how to put it in practice, this theory will mean absolutely nothing. And this is pretty much my beef with roadmaps, right? They never cover all of that hidden knowledge. They just cover, the technical topics that you need to learn, and that's not the end of the story. This is just the tip of the iceberg. So make sure you understand this before you invest your time. That doesn't mean that you shouldn't start. You definitely should pick up these topics and even apply them in your current role without being a software architect. Which brings us to the second misconception. Studying these topics top to bottom might not necessarily be the best way. Even my categorization is pretty much biased somewhat to my experience. You might have a completely different experience. So what I need from you is to take agency. This advice is a starting point, but you need to define what is best for you based on your circumstances, your journey, your experience, which industry you're working at, so on and so forth. Number 3, we all feel the imposter syndrome. No matter how experienced you are, no matter how senior you are. Don't let this prevent you from leveling up and from growing and from evolving yourself and your practice. But I have to say this. If you are performing at a software architect level, you should kind of know this already. And you're probably not going to need videos like this. These videos might be able, to give you a sense of what others might be doing and for you to gain more validation for what you've built for yourself and for the path that you are on. But if you rely on videos like this to understand what a software architect does and how a software architect needs to do their work and what type of experience and topics a software architect should know, then that is an indication that you're not at that level yet. And it's totally okay. That doesn't mean you're not going to get there. But I'm just saying, if you are a software architect, what I'm saying right now, you should already pretty much know. The last misconception is the title means absolutely nothing. I made many videos about titles in tech being absolutely meaningless, and I still believe that to be very true. You could get the title software architect. That doesn't mean you are actually fulfilling the function of a software architect. And that doesn't really mean that you are at the appropriate level. I've personally been given the title architect multiple times over my career. I've always felt that these were too big of a shoes for me to fill. And again, this is not a discouragement. I'm just saying that titles are sometimes very inflated and they don't necessarily mean what they should mean. Now, I talk too much. Let's get the iPad on and let us actually dig into this awesome roadmap. As usual, huge thanks to the creators for all the work that they put in developing these things. So let's start with, again, as usual, the P1 topics. P1 are fundamentals. Starting with a few definitions and understanding the basics as mentioned here is, pretty much fundamental. So what is software architecture? Pretty much it's the design of different types of applications. And a lot of people confuse software architecture to be the development and design of SaaS products, right? Software as a service, things that are web-based or even mobile apps. But the world of software development is much larger than this, way larger. There are architects for, embedded devices. There are people who are building software for really advanced machinery. There are people who are building software for factories, for so many different types of industries that it cannot really be reduced to just web and mobile and, this craze of tech. Tech is much bigger than what the current trends make it seem. So again, software architecture is a pretty broad topic. It's pretty much when you have the capacity to design solutions for problems. That's how I define it. And these solutions, we're not talking about, just high level stuff. The role of a software architect is just to dig levels deeper and to be able to build and design the abstractions that can help large or different fragmented development teams achieve a given solution to either a business problem or a problem in general. Now, what is a software architect? Following that definition of software architecture in general, it's the individual who's able to make things happen. I want to clarify a small misconception here because everybody thinks that a software architect is the person who leads different software engineering teams, and that's not necessarily the case. These teams have their own engineering managers. A software architect doesn't necessarily need to be up in the hierarchy. Software architecture is a function. That's how you should think about it. It's not someone who comes in and says, you need to do this, you need to do that, you need to do this, you need to do that. A software architect should be thought of as a guide, as a mentor maybe, or even a coach for large engineering teams. And this function should be thought of as the glue between compartmentalized engineering groups, whereby some people are working on component A, other people are working on a component B. The architect should be the person who can see the picture end to end and advise on the different practices, technical standards, tools, design principles to use. Listen to what I just said, advise, right? Not make the decision, because at the end of the day, an architect cannot go deep into the code, especially when we're talking about large landscapes and gigantic code bases. The software architect cannot understand this amount of this entire surface level. They need to rely on advisors for them. They need to rely on software engineers who can provide them with the necessary insights. A software architect should have the technical knowledge to be able to identify bullshit from what is actually, valid. They should be able to question software engineers. They should be able to get to the bottom of the truth. They should be able to ask why, get a response, and vet whether this response makes sense or not. This is where the technical knowledge comes in, but they're not the person who needs to make every single decision. They don't know better than the software engineers working on their own code bases. That's why a software architect's role is to actually influence decision making, but not make the decisions. Because if they are the people who make the decisions, they're gonna first of all become a bottleneck. They're gonna create a lot of inefficiencies in organizations. They're gonna make decisions for stuff they don't necessarily fully understand. And they're gonna have wide, far-reaching impact on teams because they will strip these teams from their own agency. They're gonna strip them from the autonomy. And then it becomes what type of job? Even software engineers, they wanna design, they wanna solve problems, they wanna tackle the interesting things. And it's not the role of the architect to come in and take and suck all the fun out of the job. That's my perspective again, my opinions. That's my advice for you to be an effective software architect, but also to be a person who others would want to work with. Now, I talked a lot about the characteristics. Let's move on to the different levels. And again, I don't see these as levels. I just see them as different functions. Even though a lot of enterprises and companies and corporations, they will look at, the application architecture and solution architecture and enterprise architecture as levels. They would look at the application architecture as the bottom level, solution architecture one level higher, enterprise architecture is one level higher. And why do they associate these titles with the hierarchy? Because they consider application architecture to be as close as possible to the code base, which is like one level up from being an individual contributor. And I don't necessarily agree with this hierarchy. I think it's bullshit and it doesn't make sense. I would like to think of these as different functions that can all coexist, and for these three different functions to work together, to come up with the best solution that fits the business needs and to drive the business forward. An application architect is the individual who looks a little bit one level deeper. A solution architect goes one level higher in the abstractions, and they are the people who interact a little bit more with the business aspect, right? So if solution architecture is offered as a service, they would probably be the ones who are at the forefront. They need to communicate with clients. They are pretty much the consultants. They need to think of the business problem, and they need to have a deep understanding of the business problem, and for them to come up with a technical solution that fits that problem. So they need to solve the business issue with a technical solution. They most likely will need to coordinate with an application architect, to figure out the details of the app or the product that they're working on or developing. Now, an enterprise architect is also like one level higher from a solution architect. And sometimes you will see an enterprise architect managing a team of solution architects. And again, I don't believe in this hierarchy. I'm not a big fan of it. An enterprise architect is supposed to pretty much have the holistic image of the entire enterprise. They need to be able to see everything end to end. They need to understand the business end to end. They need to understand also the technological landscape that they have, and they should be responsible for this landscape and the outcomes of it, and whether it fulfills the business functions or not. They will most likely be interacting with the C-suite level to help them understand the technical angles of the business and help the C-suite make decisions at a very high strategic level. You will see these again in enterprises. If you go to big tech or product-based companies, you will never see any of this. You will see individual contributors, software engineers, leveling up, taking on more responsibility. So for example, you will see staff engineers, principal engineers doing a little bit more software architecture. You will see them be more involved across teams, across different organizations even. So they will pretty much be fulfilling the roles of application architect, solution architect, and enterprise architect at the same time. You'll probably see the principal plus sometimes distinguished engineers play the role of the enterprise architects, where they have an understanding of all of the aspects of the business, and then they can make high-level strategic decisions that propagate across the entire chain below them. But again, these are influential roles. They don't necessarily they're not roles to dictate certain things. They might take guidance and build standards, build tools, build design principles. So for example, an enterprise architect along with the other architects, they might decide moving forward, we're going to adopt a microservices architecture that is pretty much event driven, for example. They have the capacity to do that in addition, while working with the different engineering teams to align that this is actually the best solution or the best architecture to adopt for the business and the landscape that they are currently managing. We talked a lot about the different functions, but I think it's the functions, and I think it's important for you to be aware of the distinctions and how they coexist in the market today. This is a snippet. There's obviously much more subtleties and different nuances, and you will see these applied differently across different organizations. So consider this a starting point. Moving on with the basics, design, architecture, decision-making, simplifying things, how to code, documentation. I'm pretty sure you've mastered all of those already. If you're considering, a move up to software architecture at a senior level, you probably already have reached advanced stages of these particular skills. I would say simplifying things, this is an area you should really hone, because I see a lot of people, even beyond senior, they might be great technically, but they have a big problem in simplifying problems and explaining them in layman terms. I see them relying a lot on technical jargon, heavy context, and I understand some of these issues cannot really be communicated in simple ways, but my ultimate test is always, if you can explain it to someone who doesn't understand the field and they can understand it, that means you yourself understand it very well. And if I see someone who's using a lot of technical jargon, who's really not able to explain a certain concept, that can be a signal that they themselves don't understand the issue with the level of depth that is required. And that is when I start questioning them with the 5 whys, to dig really deep and see if they have truly mastered the topic that they are talking about. Now, let's see here. There's a mention of technical skills. So we have some programming languages and there are some important skills to learn. Let's see programming languages. When it comes to programming languages, I don't want to tell you learn this or that, and I don't really care what's in this bucket. What I care more about is the number of paradigms you're familiar with. So if you've been programming for years and learning multiple languages within the same paradigm, so let's say imperative plus object-oriented heavy, you might want to start exploring other paradigms, for example, functional being one of them, or something else. That will expand your horizon. That will allow you to even see the languages you've mastered in a completely different lens and a completely different perspective. And that will allow you to make better decisions even about the topics that you think you've already mastered. Obviously, the breadth of your knowledge as a software architect will come into play here because, again, the details will be left for the individual teams. What you should be familiar with is the fundamentals and the underlying common denominators of all of these different programming languages, paradigms, and technology stacks. And this is what matters because this is what you're going to be using to base all of the or many of the recommendations and decision making on. And as you are all aware, being a software architect or a developer or whatever it is, the learning just never ends. And we all have to stay up to date and relevant, but the ability to do that diminishes with time, and the fundamentals start surfacing. Even if there are new trends, the new ways of doing things, a lot of the fundamentals are carried over. And sometimes the new trends are simply a rehash plus some rebranding of old concepts that we're all pretty much familiar with. Now comes the most important part, in my opinion, which is the soft skills and non-technical skills that you should really hone and master and really work hard on. This is what's going to be 80% of your effort and 80% of what you're going to be struggling with as a software architect. Communication, most fundamental, most important aspect of them all. Communication is so wide of a topic that it might take you years to really develop fully, and for you to be a great commander of a spoken language, and for you not only to just speak a language, for you to be able to convey ideas in a way that is attractive for others and in a way that allows others to understand you. And the way you build and enhance your communication is by developing huge amounts of empathy. Like, I found a lot of success in my career by putting myself in other people's shoes. And it might sound cliche right now, but it's not about imagining what the other person might be feeling. It's about literally putting yourself and thinking, how would I behave and how would I react in a certain environment? How would I want to be taught? How would I want to be communicated about this specific topic? It's very easy for us to get absorbed by the day-to-day grunt and the problems of every day. And it's very easy for us to be lazy communicators. But as a software architect, you have to put in the extra effort because you are in a position where you cannot really dictate things. You are in a position where you have to influence, and managing by influence is the most difficult thing because you're not responsible. You cannot dictate what people can do. You have to convince them about what they should do. And that convincing takes a lot of energy and it takes a lot of effort. And if you're horrible at communicating, you're pretty much going to be a very lousy architect who's going to have to revert back to pulling rank, or maybe even just forcing their decision on the individual development teams, and then you're going to have a horrible experience across the chain. In my opinion, a software architect is a great communicator. Next is being able to estimate and evaluate. And this goes without saying at this point in time. It's not about providing accurate estimates. Obviously, experience will come in and play a big role. However, it's not always that we're going to come in and build things that we've built before. In tech, a lot of the challenges come in because, we're building things for the first time. Or even if we're building something we've built before, many things could be different. Infrastructure could be different. The teams could be different that we're working with. The landscape that we're dealing with, the industry we're working in could be different, even if it's the same product that we're building, for example, or replicating. So yes, your experiences will come into play, but there are still a lot of variables. And your ability to estimate, given all of the uncertainty, is very important. And what's more important than estimating, we go back to communication, right? Is your ability to manage expectations. It's your ability to communicate estimates that will not backfire in your face. It's your ability to think about all the possible scenarios. Again, it's the best effort, of course, because you cannot really see the future. But it's about your ability to leverage your experience, to leverage the input from all of the different teams, to solicit the input from all of these teams, to have the awareness, right? To ask for feedback, to ask for input, not feedback even before we get to the level of feedback, to ask for input from the different teams, to question what is not being told. A lot of people will have agendas. They will share with you some information, but not others. You have to have all sorts of levels of awareness to be able to collect and compile all of this information and then to make estimates based on the information that is available. and for these estimates to make sense. And you need to have the ability to communicate these estimates in a way where you under-promise and over-deliver. This will always guarantee you results. Under-promise, promise very little, deliver way more. With time, you will probably build a reputation and this trick will, fade away. But still, it means that people can rely on you. And even if things don't go according to plan, what matters is your ability to communicate beforehand that we are slipping. It's not about being the person who's always raising red flags and always complaining about the situation. It's about your ability to inform the necessary stakeholders that we are slipping, for example, on a certain deadline for whatever reason, that we're not meeting our we're not going to be able to meet our estimates for whatever reason. The reason doesn't really matter. We can work around it. What matters is that you are aware of the reason, one. What matters is that you have a plan to work around it. If you come in, you raise a flag, you don't have a plan for how you're going to solve it, you really have no clue when this is going to be delivered, you cannot produce a new estimate, and you're not really working on getting the information necessary for you to do so, that means you're not really in control of the situation. So if you don't have all of the input necessary for you to make an estimate, you are responsible to go and fetch it, be it from people, be it by running spikes, by running proofs of concepts, whatever it is, you make it happen. Now, balancing, consulting and coaching, marketing skills, all of these are great soft skills that are very important. Balance is very critical. You cannot keep pushing your teams, for example, to deliver certain things. You have to learn and work with the different engineering managers on creating a balance where sometimes we need to work really hard and push the limits and boundaries, and other times we need to be a little bit more relaxed. We cannot really keep pushing the boundaries and raising the bar all the time. People will burn out this way. So you have to work to create a safe environment for people to operate so that you can get the best out of them and so that they give you the best that they have. Now, I can hear a lot of people come in and say, I did not really hire this team, or I'm working with a team that I have no control over, or that we have a lack of talent, or people are not doing this, people are not doing that. I don't want to hear it. It's your responsibility to, again, work with your environment, with your circumstances to make it better. If you cannot do it yourself, maybe it's time for you to leave and find another environment where you can have impact. If you really cannot impact anything, then you should start questioning what is the value of your, existence within this team. If you have no influence in anything, if people don't listen to you, if people don't even want to listen to you, if people listen to you but they don't really do, or let's say apply your advice at any point in time, then you should really start questioning, like, what is your role? Maybe you're better off being part of these teams as a developer and not necessarily as an architect. Maybe the organization is not structured in a way for you to be effective. Then you either have to fight for that, or you should really start considering moving elsewhere where you can have the impact that is necessary and that fits your function and role. Now, when it comes to tools, Atlassian, Trello, Slack, Git, whatever, I don't care. These are trivialities. Doesn't really matter which tools you use. Use whatever tool is fit for the job. You should probably already know this by now. Now, responsibilities. Let's see here. So what do we have? Tech decisions. Yeah, you can see everything is P1 now because it is what it is. Like, all of these things, in my opinion, are not even architect level. These are all senior software engineer skills. You should have a good command over them by now. So technical decisions, obviously, I wouldn't call it responsibility. Yeah, I mean, it is a responsibility of sorts. Design and architectural decisions, but again, the decision is not yours as a software architect at the end. You can make recommendations, and I would replace decision here with recommendations. Requirement elicitation, definitely, because you need to be able to ask the necessary questions and collect the input that I was referring to. You need to have the ability to collect the input that is necessary, whether people speak it or whether you have to pull it from people themselves. In your position, there's not going to be, like, let's say, a business analyst who's going to come in and do all of the work for you and come in and give you a requirements sheet. That's bullshit. If you're working this way, I'm not really sure that you really need to be an architect here. You have to have the ability to compile this information yourself, or if you have these business analysts, work with them on figuring out the true gist of what needs to be built and on creating a technical vision and a technical direction for the business requirements. And if any of these functions are not there or available, you need to have the capacity to to fit in and fulfill these functions until you're able to hire for people who are, specialized in these specific and dedicated for these areas, not necessarily specialized. Documentation, most definitely. This is the thing that you're going to be doing 80% of the time besides communication. So you're not going to be able to write code on a daily basis. You might be able to contribute to the code base. Depends on, again, because you're going to be managing a wider landscape. You're not going to be able to keep up with the code base. You're not going to be able to make contributions to as big of a landscape as when you were a software engineer focusing on a narrow area of, again, it depends on the scale of the company, of course. If you're in a startup, if you're in a mid-sized organization, it's different than working in a larger enterprise. But still, it holds. As a software architect, you're going to be doing a lot of communication, a lot of meetings, a lot of evangelization, a lot of, training, coaching, so on and so forth. And most importantly, you're going to be responsible for a lot of documentation. Either the documentation you write and build yourself, or by helping and guiding others build and maintain documentation themselves. You're going to be writing a lot of proposals. You're going to be writing a lot of design documents that you're going to be sharing with different teams. You're going to be writing a lot of standardization documentation. You're going to be doing a lot of writing. So this is something that you must enjoy, and you have to enhance your writing skills. And something we did not really touch upon yet, your ability to draw diagrams, which I'm not sure it's covered in this roadmap. And I really hope it is, because in my opinion, that's very, very important. Yeah, I see a lot of technical stuff. I'm not able to see diagramming. So yeah, let's see. Diagrams, very, very important. Beyond all of the fun technical stuff, being able to draw diagrams is going to be fundamental. So when I made a few videos joking about, what we do as architects, that we're really aligning arrows and boxes and things like that, yes, believe it. That's what you're going to be doing a lot of the time. Enforcing standards, I disagree. I mean, this is a P1 for sure, but it's not about enforcing. Again, it's about, recommending standards. It's about designing, building standards, going a bit out of the box depending on the environment, reading about standards, understanding the available standards, applying whatever has been built already without necessarily inventing the wheel. Sometimes we have to create certain standards that fit our specific environment. So don't shy away from breaking out from the common wisdom. Sometimes it makes sense, and you need to be able to judge when it makes sense and when it doesn't. Collaboration with others goes without saying. Consulting and coaching developers. This is the most important out of this entire list. And in my opinion, this is what you're going to be doing a lot of the time, not necessarily making decisions, but coaching and consulting. Now, the fun stuff, patterns and design principles. Obviously, these are P1. Well, let's see. Object-oriented programming, definitely. CQRS and eventual consistency, I would say no, not for now, because not everybody is working with distributed systems. Not everybody is building SaaS products that are, internet scale. A lot of the work of software architects is building monolithic applications sometimes, and that is okay. It doesn't mean that you can only be an architect if you are building internet scale products. If you are, fantastic, that's great experience. If you aren't, you're also valid. Your experience is still valid. You have an experience, but in another area. And that's totally okay. Building a monolith is challenging all by itself. You don't have to build microservices for you to be able to be an elite engineer or an elite architect. A lot of software architects you probably never heard of are doing amazing things. They're designing and helping teams build our infrastructure, the software that runs our hospitals, our banks, our everything that we need to live day by day. The world doesn't revolve around Silicon Valley startups and tech companies. Okay, so let's be clear about that. All right, acid, I would say it's a P1. Cap theorem, maybe not. I would say probably it's a P2, maybe even a P3. Again, this goes back to distributed systems. When you're building large databases, you could be working with like gigantic Oracle data stores that are clustered but not necessarily distributed or sharded or, partitioned. So cap theorem, it's good to be aware of it. I wouldn't say it's a P1. Acid is definitely P1, and it's also, again, software engineering level P1, not necessarily architect P1. Test-driven development, most definitely a P1. Everything about the different MVC, MVVM, MVP, which are different variations of each other. You should definitely know this stuff by now, you know, the model view controller type of thing. It's very common. It's available in all sorts of web frameworks and all sorts of mobile frameworks. And again, it's not about religiously implementing these things. It's just about being aware of the patterns so that you can make use of them whenever it makes sense. Actors, I have no clue what this is, so let's put it aside. Solid, I would say definitely. Domain-driven design is one of these things where, I mean, I love how this field, we always put labels on things and talk about them as if they are being invented or discovered. Even though there are many people who are implementing them without necessarily knowing that they are doing that. Domain-driven design is one such thing. I think it's very important for you to read a little bit about it. It's not important for you to be dogmatic about it. Again, the same applies for test-driven development. You need to understand what are the benefits of using these tools. That's how you should think about them, tools. You should use these tools for your benefit. That doesn't necessarily mean you have to be dogmatic and follow every single instruction step by step in your implementation. I wouldn't qualify domain-driven design as a P1. I would probably have it as a P2. We will see in a bit. All right, moving on to security. We have hashing algorithm, private key infrastructure, authentication strategies. That's definitely P1. At this point in time, you should be familiar with the different authentication mechanisms, with different hashing algorithms and how you can secure and store credentials safely. Yeah, security should be top of mind for you, and you should always remind everybody of good and safe coding practices, and you should also show people how they can develop their knowledge and abilities in this area. And you should definitely be one of the people who always strive to push for better security. All right, moving on. On the left-hand side, you will see a list of architectures. And this is, I think, the meat of our conversation today. This is where, in my opinion, there are a few things that you should know. There are a few things that are optional. And let's categorize them just like we did with the rest of the stuff. So, serverless. Is that something that you must know? Or is that something that is optional? And is it P2 or P3 even? I have a controversial opinion about this one. It really depends. So if your organization has already made decisions to go serverless and you're coming in as a software architect, either you've been promoted into the role or you're joining a company that's doing serverless already, then this is most definitely a topic that you should be familiar with. However, if you are in a company that has not adopted serverless and you're not in command of all of the other architectural patterns, I would not recommend that you start with serverless. I would recommend that you build a stronger foundation with other stuff, because in my mind, serverless is like the last stretch. You need to understand that serverless architectures are driven by cloud providers. Why? Because cloud providers, it's in their best interest, to provide you with platforms that they fully manage, because they can optimize the operational costs of managing that infrastructure. And by doing this optimization, they don't reduce what you pay. It's quite the opposite. They increase their margin of profit. They alleviate you from dealing and managing with infrastructure. It's all a black box. You don't really configure anything. You barely configure surface level stuff. And then you orchestrate things, obviously. And then you leave it for the platform to auto-scale itself, to deal with different levels of load. And then at the end of the month, you settle that bill. Serverless comes in with a lot of different promises. I have not done serverless implementations before, so I cannot speak as to whether they fulfill these promises or not. And by that simple fact that it has not become a fundamental part of the wider ecosystem, right? Even though it's an upcoming trend, I would not consider it a P1. That's for sure. So moving on to microservices. This is a bit controversial. Microservices, I would consider it not necessarily P1 as well, probably P2, because there's a lot of movement from, monolithic architecture to microservices or even service-oriented architectures. And I can understand this. This is a fine transition because it can provide some value and benefits for you and for your organization, but it's also not necessarily something that you would start with. In my opinion, microservices is an evolution of your architecture. It's like the second level evolution, not necessarily something that you would do from the get-go. And this is a lot of mistake that I see in the field, is that a lot of companies start by adopting microservices from day one. That shouldn't be the case. I feel there's too much operational overhead for an organization to be able to cope with implementing microservices from the get-go. So that's why I would say microservices is not a P1 topic as well. I would definitely say client-server architectures, yes, you should most definitely know, especially if you're working in web. Client-server is like the foundation architectural pattern that you will see over and over and over and over again. So you should familiarize yourself with it and with all of the different facets of it. You should familiarize yourself with how you can scale it and how you can manage it and what are the pitfalls of this architecture, limitations, and what are also the benefits of it. I'm not sure what layered refers to here, so we're gonna skip it. Distributed systems, I think it falls with the same bucket as serverless and microservices. It's again an evolution of an architecture. It's not necessarily what you would do from day one. As a software architect, you could be completely fine designing for a large monolithic application, and in my opinion, for 80%, if not even 90% of the cases, that's what you're going to be building for. You're not going to be building for internet scale. You're going to be building for the scale of your organization, for the scale of maybe thousands of customers or enterprises. It depends whether you're building a product that's B2B, business to business, or business to consumer. It varies. You might be building at a scale of a region or even a country, but you will not be building for the scale of the internet. And in my opinion, unless you're building products that are of a gigantic magnitude, and we're talking about millions of requests per second or queries per second and whatnot, then distributed systems will not necessarily come into play. Service-oriented architecture, however, on the other hand, I would say it can go hand in hand with, client-server, because it's not microservices per se. Probably I would put it in the same bucket as, domain-driven design, whereby you would start modularizing pretty much your solution. So instead of it being a gigantic monolith, and even if it is a monolith, sometimes the monolith can depend on other external services that are built, managed, maintained, and they have their own separate independent life cycle. I would say service-oriented architecture should come hand in hand with learning the client server architecture and also building monolithic applications. And I would definitely consider it EP1. I'm gonna talk a little bit more about distributed systems when we talk about P2, but these are the fundamental architectures that you should pick up from the get-go, and for you to build up experience, knowledge, and know-how before you move on to the next stuff. Now let's see here. We have working with data. Well, you should definitely know how to manipulate data and how to manage data at this level. I would consider data knowledge a P1 level. However, building data warehouses, dealing with big data problems, crunching gigantic amounts of data, that is very context specific. And that doesn't necessarily mean that you need to be well versed in all of these areas from day one. However, I would say being familiar with SQL databases and no SQL databases from the get-go is definitely a P1 topic. Maybe even some, extraction, transformation, ETLs basically could be a topic for day one, because you might be asked for reports, or you might be asked for, not necessarily you designing, but you might be asked for what can we design from whatever we have. And you should be familiar with some of the limitations of your pipelines and what data you can extract and what you can actually do and report on with the data that you have. So familiarize yourself with these basic areas. When it comes to data warehousing, using Hadoop, Spark, MapReduce, and whatever, all of that other stuff in terms of tooling and analytics, so on and so forth, we can leave that as part of P2, maybe even P3, and it really depends on the organization you're working with. And most likely there's going to be another architect who's going to have these topics as their speciality. Being a generalist is fine, but if you want to dig deeper, I would say this is a bucket that can be managed by another architect that has more in-depth experience and knowledge in this particular area. Now, when it comes to APIs and integrations, definitely you should be familiar, let's see, with pretty much everything in this list, in my opinion, as P1. Why? Because gRPC, not necessarily gRPC, RPC, let's put it that way. gRPC is just one flavor that was created by Google for, remote procedure calls. You should be familiar with what this is, what benefit does it bring, especially if you're going to start building with a service-oriented architecture. You should be familiar with how different services can communicate in between each other, and what are the limitations of REST communication, and what are some of the benefits of using something like gRPC, where you have contracts that are specifically defined. You can stream data, which is much faster, compressed. You have fixed contracts that are clearly defined that you can manage, version, and maintain over time. So you should definitely be familiar with this. When it comes to Enterprise Service Bus and SOAP, it also depends on the technology stack that you're using, but you should at least be familiar with what these are and what they refer to and how you can manage them. GraphQL, same thing. You should definitely be familiar with what GraphQL is. You might not necessarily have done a GraphQL implementation before, but you should know what it offers, what are some of the benefits of it, why is it different, and why does it need to be a separate item on this list. REST APIs is definitely one of the definite fundamentals. A lot of the web today and services communicate via REST and HTTP calls. You should definitely be familiar with the best practices for designing and building RESTful APIs. What are some of the industry practices and how you scale them, how you version control them, how you manage their own life cycle, so on and so forth. So these are very important. Now, BPM and BPEL solutions are also very specific to certain industries. So if you work in finance, for example, or banking, you might necessarily see these a bit more often. In other areas, for example, where if you're building software to manage operations, you will see a lot of different instances of the business process management software, and you need to be familiar with how you can program them and how you can design these to fit the business objectives and business purposes. Message queues, I would definitely highly recommend that you familiarize yourself with how message queues work. They are going to be a fundamental component of making sure that your infrastructure or architecture is a bit more resilient, and it can also cope with different amounts of unexpected, unpredictable loads, because your queues are a bit more elastic than having to deal with everything in sync, and they offer you this buffer that you're quite going to need whenever you start dealing with problems at scale. And even if you don't necessarily deal with problems at the gigantic scale, sometimes communication between two specific services is quite heavy because of the nature of their design, that you can alleviate this pressure and even the back pressure by introducing queues. So I would recommend that you develop a good understanding of how you can use message queues, what are the different protocols available, and the different integration modules, libraries that are available, and how they gel and fit into your entire landscape. Now, let's move on to talk about web and mobile. Obviously, when it comes to web, it also varies. Not everybody works in web, and not everybody's gonna be, dealing with these things on a day-to-day basis. So from this entire list, I would say, familiarizing yourself with the W3C standards. I wouldn't say you need to know every single thing, but you just need to be familiar with the common, web standards and what are some of the benefits of introducing them and why they were actually introduced, so that maybe you would leverage them or advise the team to, adopt a lot of these good practices. Now, when it comes to, for example, stuff like micro front ends, this is a pretty nascent trend and a topic, and it's also an architectural pattern where basically you're not necessarily inheriting, it's inspired a little bit by the service-oriented or microservices architecture, and they're sort of adopting that and bringing it to the front end. I can understand some of the appeal. I have not implemented a micro front ends architecture before, so I cannot really speak as to the benefits and, the best and worst case scenarios. But I don't know, I'm a bit skeptical when it comes to these things, because it feels like the topic and the name is a bit hyped up. I have to see it in action, maybe even read a few use cases about it to really evaluate whether this is something fundamentally good or something that is a bit overhyped, or it's sort of a rehashing or a rebranding of a pretty familiar concept. But anyway, let's skip it for now. I would not consider it a P1. Now, single page apps and all of the other variations of them. Yes, you should be familiar with them if you're building a product in that space. If you're not necessarily building a product in that space, then these will definitely be optional topics because they are very much context specific, right? You should know what they are, You don't necessarily need to be an expert in them. And I would consider these, there are certain people who have built this stuff, they have built an experience in that stuff. So if your organization is building these things and you want to be an architect in your organization, then you should definitely familiarize yourself with these. Same thing comes for React, Vue, and Angular. And what I would recommend here as a generalist, let's say, is not necessarily to have in-depth knowledge of them, but building a few applications using any of these frameworks will just give you a feel for what they are about. And it will give you an idea of why they are popular and why do people go back to them. And you will notice that there is some value in them beyond using vanilla, JavaScript. I wouldn't say the problem starts when you start using React, Vue, and Angular for everything. This is where the problem begins. They're not designed to be used for pretty much everything. They have very specific use cases, and you should evaluate their importance based on the use case at hand. Again, there are tools. They're not a hammer that you could just use and smash every single problem in your way with it. And this is your role as an architect, which is to evaluate the benefit of using one tool over the other and whether this tool brings in value to your life or not. Now, functional programming and the other paradigms, I would say that's a P1 just because you need to familiarize yourself with how these things work, different paradigms, and I'm not sure why they fall under the category of web and mobile. I would say you need to understand a little bit what functional programming is, what reactive programming is, how to do things async, and not necessarily doing everything in a synchronized manner. Now we have a few areas left, so let's move on to talk about networks. So the OSI model, TCP/IP, HTTPS, proxies, firewalls, and all of this stuff, that's definitely P1 knowledge. You should at least be familiar with these. These are pretty much basics. You've taken them in any network course. If you haven't taken a networking course, I would recommend that you take one. And I would recommend that you really know what they are about, how to implement proxies, how to set them up. They're not really that big of a deal, so if you do them once, you just pick up the knowledge. You will have networking experts, that's for sure, but you need to be able to understand what features a firewall has. For example, what is the difference between a regular firewall and the Palo Alto? You're gonna have to make these decisions, especially if you're working in an enterprise context. You have to understand what the benefits of each, why one is more expensive than the other, what does it bring into the table, and why would you want to adopt something like that? All right, now comes the fun part when we talk about infrastructure. So let's move on to this region over here. And what do we have? We have infrastructure as code. So it really depends on the context. A lot of these topics are very much context specific, and they depend on the organization you work with and the types of projects that you're leading or you're working with. So infrastructure as code, I would not consider it as a P1 topic unless you're working in an enterprise that is deploying to the cloud and you're managing infrastructure all the time. You might be working in an environment where you don't need that much infrastructure, and this is not a topic that you might need to invest a lot of time in. However, if you're working in an environment where you're deploying a lot to the cloud, your infrastructure is very dynamic, it's changing all the time, you're scaling, you're adding things, it's a very dynamic environment, then you definitely need to understand what infrastructure as code is and what are the available tooling in place, tooling like Terraform, so on and so forth. And I made another video about infrastructure as code and how you can leverage GitHub Actions and Terraform, to deploy and to provision infrastructure in the cloud. I would recommend that you go and check it out. Next, you need to be familiar with cloud providers, that's for sure. Nowadays, lack of familiarity with cloud is not a good thing. Even if you are on-prem, you should be familiar with what the cloud offers and what are some of the benefits that the cloud brings. And it's not really that big of a deal. You can just take one course and it will give you like a large, nice overview over the different services that are provided by cloud providers. And as I always say for everybody, don't be intimidated by the amount of services that are offered by cloud providers. A lot of these services, you've probably seen them before. They just are offered in a managed form. That's number one. Number two, if you have covered the fundamentals that I've just spoken about, you will notice that a lot of these topics are borrowed in cloud as well, but they are offered as a higher level of abstraction, and they just give you a nice fancy UI and maybe an interface with which you can manage this infrastructure, but it's not really any groundbreaking thing that is coming, from another planet or something. It's pretty much the same concepts that just are borrowed and put in a cloud context. And if you study one, and if you invest your time learning about the different details of one, you will understand also how other cloud providers are doing it, because pretty much they're all in the same competing space and they are competing with each other to offer the same services. If one of them offers something new, then the rest will also follow very shortly. Next, serverless concepts. We talked about it. I don't consider this a P1. Start by familiarizing yourself with the different cloud offerings. Then you'll understand the purpose of serverless and why it exists and why it is the next evolution of just moving to the cloud and building on the cloud. But it's also context specific and it depends on your environment. Linux and Unix is definitely a fundamental topic. By now, if you are even a software engineer, I would consider this as a fundamental topic for you. So there's not much to talk about here. Service mesh, I would definitely not consider it a P1 topic, but it depends. If you're doing microservices, understanding what a service mesh is and how it works, what are some of the benefits of it, trade-offs, what are you losing if you implement a service mesh, is very, very critical and important. So it's definitely not a P1 topic, but familiarize yourself with what a service mesh is. Don't be intimidated by the name. It's, again, all of this becomes much more intuitive when you start with the fundamentals. So start by understanding how you can split your monolith into service-oriented architecture, and then how you can minimize and restructure your services to become smaller, more nimble, have their own life cycle, expose specific defined contracts, how to partition your database. This is very important. I see a lot of people doing microservices while their database is still this gigantic blob that all of the microservices tap into and extract information, and that's not microservices. That's, I don't know what to call it. It's like a very bad hybrid and one of the bad implementations of microservices. But again, put service mesh on the side for now. CI/CD, that's definitely one of the main topics that you should be familiar with. You cannot be a software architect, in my opinion, if you don't understand your integration cycle and if you don't understand how you are building and deploying and delivering your software. Not everybody works in the cloud, so not everybody can actually have continuous deployment and continuous delivery. A lot of us work in regulated environments where, you need to have multiple eyes. There needs to be multiple approvals for, when you deploy and how you deploy. You might need to bundle things into releases because you are releasing software that needs to be installed on machinery or hardware that you don't immediately have access to. And that hardware might not be connected to the internet, and you cannot really automatically update it. So all of these things prevent you from doing continuous deployment and delivery, but you need to at least be doing continuous integration. It's not acceptable anymore that we are in this day and age with all of this tooling that is available, and we are still doing manual integration. That's just not acceptable. No matter how complex your project is, no matter how complex your software is, whatever it is, you need to modernize, and you cannot have engineers wait for days and weeks before they discover whether their patch or change has broken something else. It's just not okay. Moving on, containers, yes, again, they have been so democratized to the point where it's not really okay for you not to be familiar, at least, or have played with containers. And I'm not saying that you need to modify all of your, packaging process and all of your infrastructure and all of your pipelines and workflows to accommodate containers, but you should have played enough with containers to understand some of the benefits that they offer, and for you to find ways with how you can integrate containers into your day-to-day workflow. It's not okay anymore for you not to be familiar with this concept, but it's okay not to be implemented, with your entire landscape. That's totally fine. Cloud design patterns, I would not say this is a P1, just because first familiarize yourself with cloud providers, then you can start thinking about what types of patterns you could use to mix and match different services to solve a variety of problems. And again, a lot of people start with patterns. That's the wrong thing to do. First, start by the basics, the vanilla, the stupid. Implement it in the most fundamental, idiotic way you can think of. And then you will start identifying the patterns yourself. You don't have to read a book about patterns to understand patterns. Patterns are simply, from the name, you should understand from the name that they are simply ways that have been discovered and simply labeled by people. And how did they discover these patterns? By doing. So you yourself start by doing, and you will discover these patterns yourself, and then maybe you'll even invent names for them yourself. And what's nice is when you go and read about patterns, you will see, oh yes, I recognize this. Oh yes, I've seen this in the field. Oh yes, this I know. Oh, this is called this. Okay, great. Because at the end of the day, who created these patterns? It's just people who are practitioners in the industry. They have done a lot, they have seen a lot, and they have seen things repeat. And by the fact that they repeat, they become a pattern. That's all there is to it. They're not a playbook for how you can do things the right way. Patterns are not, or pattern books are not cookbooks. You know, they're not a recipe. And you should take this away from your, mentality. Don't be dogmatic about these things. Again, they're guidelines. They're not necessarily exact ways for implementing things in a certain way. Now, let's move on a little bit to this side. I see some controversial stuff here. So, PM, ITIL, Prince2, I have no clue what these are. So, certifications, probably project management certification and things like that. Let's put it this way. Nobody's going to like this. I think certifications are bullshit. Knowledge is important. Getting the information is important. Getting certificates means absolutely nothing. If you show me 100 certificates, I will not be impressed. Talk to me about what you've learned. And yes, if we have a nice, interesting conversation, I will be more impressed by that than by you showing me 100 certification of stuff that you probably have never even implemented before. Because these certifications are bullshit. Why? Because you can go study some topics, you can go do an exam, but what does that tell me about your ability to implement them? The nuances, the actual value of this information is in how you can bring it to an organization. This is the challenge. It's not about you knowing these things. It's about how you can bring them to an organization, how you can implement them in an organization. And this is where it breaks. And this is why I think certification is a load of crap. Save your money, study the material, but take courses. But certifications, yeah, they're nice. They're nice. If you have a certificate, yeah, you can just put it on your LinkedIn or something. I don't know. Now, management, Agile and Scrum. So yes, they are fundamental, but I disagree that Agile is something that needs to be taught. Agile has been bastardized. People are not going to like this. Go check out my video about, Agile and Scrum being the new type of waterfall management. Agile is not about a specific set of ways with which you can do things. For the love of God, Agile is not about a set of practices. Agile is not Scrum. Agile is not Kanban. Agile is none of these things. Agile doesn't necessarily need to even have a name. Agile is simply allowing the teams to self-govern, to come up with processes, practices, and be flexible about the implementation of these processes and practices. It's about us not being dogmatic. It's about management not necessarily enforcing very specific ways of doing everything. You understand? This is what Agile is about. It's not about chaos. I'm not sure why people think that when we say teams should self-govern, they think that, it's chaos. No, it's not. For the love of God, it feels to me like there's a layer, people who contest this and say that teams will be governed, will be in a chaotic mode, are pretty much middle managers. So they're not high-level executives, but they're also not, individual contributors who are building things. This is the middle management layer. The middle management layer justifies its existence by implementing practices such as Agile and Scrum, and I don't know what. I don't know how to fix it. Okay? I don't know how to fix it. Management, they need reporting. Individual contributors, they need a bit more clarity on what to do. There needs to be a layer of people that provide this clarity. That's how I see it in my head. It's not necessarily about the management managing and telling everybody what to do. It's pretty much about all of these layers supporting each other so that they can function together. And this is what Agile is about. If these 3 or 4 or whatever layers can figure out mechanisms to coordinate that are both effective and they work, to spread information top down and bottom up, then that's fine. That's it. Let's just move on with our lives. Let's get work done. And there's really no need for all of this chaos of modern Agile. And for, oh my God, don't let me start about less and safe and all of this crap. I'm going to put it here as P1 just so that you're familiar with what these things do and for you not to implement them. And a lot of people are going to come in and say, what are you talking about? This is bullshit. This is whatever. I don't care. Right? These frameworks are horrible. They make everything very rigid. They make everything very fixed. I've been in meetings where people are arguing about story points. For the love of God, you don't even understand what the concept of story point is if you're arguing about story points. Story points is not about providing estimates, that you can bubble up and that you can commit to. Story points are not about putting on a piece of paper that the team did last week 50 story points and this week they did 40. So the team is slacking. We should push them now to do 60 story points this sprint because they need to make up for what we lost in the last sprint. And again, I can make a whole video for 1 hour ranting about the bullshit of these frameworks. All I need to say here is, yes, familiarize yourself with them, pick and choose and discuss with your team and organization and leadership teams what works, and implement whatever requires the least amount of effort from everyone, but that keeps everyone in the loop and that makes sure that everybody is as productive as they can be. That is the whole point. Figure out what you need to optimize for and then design your process by communicating with others, and design your process in the way that makes everybody happy and effective. Now, a lot of people will say these frameworks are P1. I don't know what these first two are. I know about UML. I don't know if it's really a framework. I know about TOGAF, and I know a lot of enterprises, especially in Europe, request this TOGAF certification, and I don't know what. I never needed it. I've seen it. I've seen customers ask for it. Some of these enterprises that ask for it, I personally don't feel like I want to work there, just because the simple fact that they're asking for something like this is already indicative of the culture and the type of environment that resides in these enterprises. I'm not saying there's anything wrong with that. That's fine. Maybe they have some requirements for people to be certified in a certain thing. I don't feel like I can operate in similar environments. Familiarize yourself with these. I wouldn't say these are necessary for you to be able to execute and function effectively as a software architect. Now, enterprise software, we can talk a lot about these things. I would not consider any of these to be P1. Familiarize yourself with whatever is necessary. Some of these things you'll find on the job, other things you will not. If you work in a startup or in a mid-scale company, you're probably not going to have even the money to invest in some of these products like SAP, or it really depends. It depends. I'm not going to consider them P1. These are very context driven. So after all this talking, we have categorized everything that is P1. All that remains now is to categorize stuff that is P2. So let us do that very quickly. What I would consider as P2, and again, to remind you, P2 is pretty much working knowledge and professional knowledge. Let's see if there's something missing here. Maybe I would say microservices would be considered P2 at this point. At least familiarize yourself with what microservices are and what they bring to the table. Everything else has already been covered under P1. Now, when it comes to P3, going above and beyond, right? Now, when we talk about serverless plus microservices, this is, I would consider definitely this is something as a P3. Layered and distributed systems, this is definitely P3 if you know it. If you can bring it to the table right away, fantastic. I would not consider this fundamental for you to start working from day one. We talk about this type of stuff here as P3 because these are, in my opinion, sub-specializations. If you did not really focus on data before, you might not necessarily need to know these things to function. But if you are a software architect in the realm of data, you definitely need to know a lot of these topics. That's why it's a P3. So I'm going to add these over here as well. Micro front ends, definitely a P3, and maybe even a P4, I would say. It's optional. Even if you build like large scale front ends, let me actually fix this. This should definitely be a P4. Service mesh over here, that's definitely a P3, optional. If you're doing microservices, you should know about this stuff. P3 are cloud design patterns. So once you understand what your cloud providers are offering, you can definitely start tackling these things. Yeah, everything else has been already labeled. Now let us very quickly do what is P4. And I think there's a couple of topics here that are P4. Let's see, eventual consistency. Yeah, this goes hand in hand when we talk about microservices. So actually, let me fix this, because if it's already, if we consider microservices to be P2, this should definitely be a P3. And then let's see what's missing. Micro front ends, I would consider this topic to be completely optional. There's a bit of overlap between what is optional as well, but I think this completes the roadmap. And I hope that I've given you enough context to make sense of what this roadmap is and how you can actually approach it. And of course, this goes without saying, there's plenty of stuff that is not in this roadmap. So I cannot really discuss the completeness. I think it's a great starting point. I'm not sure about its completeness though. It's very difficult to assess this from this review, but I would say when you get to the point where you can understand this categorization that I just did, I think you'll also be at a good point for you to assess what is missing from here. And again, don't be dogmatic about this learning. Don't be dogmatic about this material. Just take it as a set of guidelines, things that can, enhance your understanding, that can give you just a new dimension to think about, a way for you to figure out what you don't know yet, and for how you can augment your learning journey so that you can keep on moving forward. And as with everything, our domain, and pretty much any other domain, is endless in terms of knowledge. So keep on learning.